Good afternoon. My name is Jeanette Matthey, Head of Field Services for Cattle Information Service, and I would like to welcome you to the CIS and IDEXX webinar, Pregnancy for Profit. Today we will be covering heat expression, detection and PAG testing, the economic importance of getting cows in calve, pregnancy success dependencies, and a vet's perspective on the use of PAG testing. The format for this afternoon will be a presentation by our honorary speakers, Hilary Dobson and Owen Atkinson. We will then have a question and answer session for our listeners. If you would like to ask a question, please click on the chat button at the bottom of the screen and type in your question and then submit it. The questions will be collated and answered at the end of the presentations. I will now hand over to our first presenter, Hilary Dobson, Emeritus Professor at the Institute of Veterinary Science, the University of Liverpool, who will be talking about heat expression, detection and PAG testing. Hilary, it is over to you.
First of all, I'd like to thank everybody who's been involved in putting this seminar together. It's been useful and interesting for me, and I hope it will be for everyone listening. And I'm looking forward to comments and questions about some of the ideas that are going to be presented. Just to let you know where I'm coming from, I've been at the Liverpool Vet School. I started there more than 50 years and I've worked there continuously since. But I also am married to a dairy farmer and the mother of another dairy farmer. And we milk 150 cows through 3 robots. So I kind of have an insight into what's going on. So I want to talk to you today about managing herd fertility and where PAG tests can come into that, whether you're a farmer or a vet. The first hint that a pregnancy has been established is that there's no heat seen after insemination. But I just want to explore this no heat seen business a bit further and share with you some of our studies that we've been doing on the expression of heat behaviour. In one very detailed study, we had 67 cows being milked. Every cow had a neck collar and a pedometer, and milk progesterone was measured every other day. And the animals were watched normally by the farm staff. And as part of a much bigger study, they were watched almost every day. Almost for all the hours every day by research scientists. I'll just give you a few of the results. This is a perfect cow. Progesterone is in green. Pedometer, the results from the pedometer are the dotted line, and the neck collar is a brown line. And there's time after calving along the bottom. It's the same in the following slide. So this is a perfect cow. The animals were all synchronized with prostaglandin to begin with. And the green line is the progesterone, and you can see this animal is cycling away quite happily. At the first potential heat, the neck collar saw the heat. The neck collar saw the heat, the pedometer saw the heat, but the animal wasn't served because it's too soon. As it happened, at the next potential heat, when progesterone was low, 20 odd days later, again, the neck collar saw the heat and the pedometer registered a value. At the next potential heat, the farmer saw the heat and was happy that it was now time to inseminate this animal, and bingo, progesterone remained high and she was PD positive sometime later. If only they were all like that. Then, unfortunately, some heats are missed by each methodology. Again, progesterone in green, pedometer in black, neck collar in brown. Days after calving, the same scale as before. And you can see here in this animal, The neck collar and the pedometer both registered, and the farmer saw the animal standing to be mounted, but nobody's going to inseminate an animal this early. The progesterone went up and came down again for another potential heat. The neck collar didn't see it, and it just so happened the calculations within the pedometer did actually see this heat here. Along went progesterone. The next potential heat, the criteria weren't met in the pedometer to register the heat. The neck collar didn't see it either. The next potential heat, the neck collar didn't see it, the pedometer didn't see it, but the farmer decided to inseminate it because it was getting late and heat signs were seen. She didn't conceive. She came into heat again. This time, everybody saw it. The animal was standing to be mounted. She was inseminated. The neck collar saw it. The pedometer saw it. And bingo, she got pregnant. So there are quite a few heats where the animal is not expressing the heat. And it's that concerns me. So using all the methods of detection on every cow in this study, 25% of the potential heats were missed. And the question is why? Heat was not actually displayed by the cows. So of course nobody saw it. But why was heat not displayed? Looking now and comparing those heats that were seen with those that were missed by farm staff, neck collars and pedometers, potential heats were missed in cows with high lameness score greater than 2 on a 1 to 5 scale. They were in low body condition score, less than 2 on a 1 to 5 scale, and they had higher milk yields. So, what is disrupting fertility in cattle? These are some studies that were done some time ago from a group, several different publications. Normal animals got pregnant to an insemination on average about 82 days after calving. But with these different clinical conditions, it took longer to get the animals in calf. So there's low body condition score, took an extra 8 days. Milk fever took longer. Mastitis, by now, we're looking at nearly 12 days extra. Dystocia, retained membranes, endometritis. Caesarean took a really long time, but then we have got the problem here that the farmer sometimes doesn't inseminate the animals because it seems a bit unfair to inseminate an animal too soon that's had a caesarean. But let's just look at, the clinical conditions highlighted in red all affect uterine activity. So they're fair enough again that there should be less fertile. But what about something wrong with the mammary gland, increasing conception, and lameness? Something wrong with your feet, affecting what's going on in the uterus? I think we have to concentrate on reducing the incidence of all these conditions. Just think of all the money and effort that's gone on and looking at the research and the farm plans and what have you to reduce mastitis and lameness. All that money and veterinary attention. And I would be quite keen that instead of putting hands up pregnant cows to confirm they are pregnant, much more attention is taken by veterinary surgeons to deal with these clinical cases. So why doesn't the cow show heat? Got a headache. Not just that. Cows with problems don't want to get pregnant right now. It's not in their best interest to get pregnant, but they may want to later, so they reserve the right to get pregnant on a future opportunity. So let's now talk about pregnancy and PAGs. and think about how pregnancy is established. Basically, cells from a live, and I emphasize a live fetus, those cells make and transfer pregnancy-associated glycoproteins, PAGs, to the lining of the dam's uterus. Let's just look at that in diagram form. As soon as the fertilization takes place, the next week or two, the embryo starts to elongate to cover as much area as it can of the lining of the uterus. So here's the embryo itself. Here are the membranes starting after a few days of pregnancy and contacting the maternal side. Looking at this little bit in more detail, here again, fetal membranes on the top here, lining of the uterus underneath. And I'm going to concentrate on these binucleate cells. They've got 2 nuclei. I'm going to concentrate on them because they make the PAGs, pregnancy-associated glycoproteins, these little black dots. And what actually happens is these cells migrate. So you get binucleate cell migration. Again, I'll emphasize you need a live embryo fetus to do it. So these binucleate cells make PAG, more and more black dots start appearing. They fuse, these cells fuse with the maternal lining of the uterus, and they transfer the black dots, the PAGs, into the blood and then into the milk so that we can measure them. But I just want to remind you, you know already really, that there are pregnancy losses, especially early on in a pregnancy. So if we look now at approximate timing of events after insemination in normal cows, and look at the time, 24 hours after heat, there is an ovulation. 98% of them actually are successful at ovulating. There are approximately 2% that fail to ovulate. Assuming they've been inseminated, day 2, fertilization takes place, and there are 85% of those are successful. So you've lost another 13% 2 days after insemination. Day 4, the conceptus enters the uterus. As many of you will know, embryo transfer can take place around day 6 or 7, whilst the embryo is still very spherical. But between days 8 and 13, the embryo hatches out of its packaging and you get this membrane elongation. But that only occurs in about 70% of animals. So now we have another 15% of losses before the animal is going to get to when we might expect her to come in heat again if she lost the pregnancy. Day 14, 15, we have what's called the maternal recognition of pregnancy. In other words, the fetus embryo is telling the mother, I'm here, don't get rid of your corpus luteum. And that, again, incurs another 15% losses. Just to carry on, interdigitation begins around day 21 to 23. That's when the membranes of the fetal membranes in the uterus start to get closer contact. There's expansion to cover as much area of the lining of the uterus as possible. And there is the binucleate cell migration. As early as day 23, and I think it's just amazing, you can see the fetal heart start beating. And in fact, the fetus is more or less, the embryo is more or less fully formed around day 23 after insemination. Day 28, the fetal sac remains spherical, and that's what vets are looking for when they're doing ultrasound pregnancy diagnosis. Weeks now, 5 and 6, you get distension of the uterus, which is when rectal palpation can confirm that the animal's pregnant. One uterine horn's bigger than the other. But we're now only down to about 50% of animals who get to this far. Day 6 to 7, the sexual differentiation, one of the final events for maturing the fetus. And weeks 8 to 9, the vets can actually carry out sexing by ultrasound to see the genitalia start to form. So there are losses, but I want to tell you now about some data given to me by IDEXX, which shows that the PAG values, which shows that the PAG values in a large number of herds in Denmark, in nearly 300,000 animals of differing breeds, you can see with time in pregnancy that the black line is the average PAG value, and it starts to increase as pregnancy proceeds. There is an annoying dip here, and I'll come to why it's annoying in a minute. But the blue lines show in here the majority of the samples will lie in here. So if you take one individual animal, its value may be here, but it will always be higher after day 100. So, what I forgot to emphasize was that the concentrations are really quite high out here after when the animal's being dried off. Of course, there's still a bit of pregnancy to go, and they still remain quite high. And they're high because there's after calving, because there's a very slow decline in concentrations occurring in the days after calving. So it takes about 30 days for the values to get below into the negative values for PAG. So the suggestion is that you don't test animals before 60 days post-calving. You may say, why 60 days? But of course, you've got to inseminate the animals in this period till you get to day 28 later. If we now look at what happens with a pregnant cow, the scale now is much larger, so this is a much shorter length of time here. And we can see that the PAG increases in a pregnant cow, and it's best to not start sampling until after day 28. A farmer rang me last week saying the way he uses PAG, and he's been doing it for 3 or 4 years now, he arranges a vet visit a couple of days after the milk recording day, so that he's got the results of those animals that are pregnant. So the farmer does not need to think about those any longer. And the vet can then deal with the non-pregnant cows to do something about them as soon as possible. The accuracy at these different times in pregnancy for PAG is very high, as is the accuracy for ultrasound. But remember, I talked to you about pregnancy losses that take place. For example, if embryonic death takes place around day 35, the concentrations of PAG decrease very quickly. And that's because I was emphasizing to you before that you have to have a live embryo for the PAG to be transferred to the maternal system. So it takes about 8 to 10 days to give a negative result. So to minimize, there's a large number of those animals, remember, to minimize the economic effect of early embryo death, I'm suggesting that 2 samples of PAG are taken at a 30 to 60 day interval at the next milk recording to be absolutely certain that animal is pregnant. Obviously, if it's not pregnant and the values are down here, then you don't have to take the second sample. But I'll just remind you again of this dip here for the next few slides, because there are some things that are sent to trials, including later fetal death. We did a study looking at corpus luteum function to assess by progesterone, measured estrogen sulfate to look at placental function. Estrogen sulfate is produced by the placenta from day 100 onwards. And I happen to be looking at pregnancy-specific protein, which is another compound, very, very similar. There are about 25 different versions of pregnancy-associated glycoproteins. And that assesses fetal well-being. So if we look here now at the scale on the bottom, and progesterone stayed high throughout. Estrogen sulfate, as I say, increases, so the fetal membranes are fine. But in actual fact, PSPB or PAGs are declining quite a long time before abortion takes place. Look at the length of time it takes for the fetus since it died until it was actually expelled out of the dam. So if vets are using PAGs to monitor what's going on, if there's a problem of fetal death in a herd, please remember that problems could occur much earlier than when the fetus is actually expelled. So monitoring fetal death, I'm suggesting you take 2 PAG samples and you have a problem if the second sample result is lower than the first one, but you have to be over 100 days, as I said before, because there's an annoying dip early in pregnancy. Another thing that's troublesome is heat in pregnancy. It has an 8 to 10% incidence in dairy cattle herds. The follicles are there. Progesterone in blood or milk is high, and I have no idea, and I've not heard anybody else come up with a good idea, why it occurs or how it occurs, but it does occur. But you can use PAG when an animal shows heat in pregnancy to check what's going on. 2 PAG samples. You have a problem if the second sample is lower than the first after 100 days. Even more annoying, in abattoirs, 33% of animals are culled for subfertility. They couldn't get back in calf. Okay, there's usually more than one reason that an animal's culled. But if you go to the abattoir, 25% of cows are actually pregnant at all stages of pregnancy. I'm not saying these 25% are exactly, definitely part of these, but there is evidence that they are. And I'll give you that evidence in a study done by Sally Ashford. She went to an abattoir and asked the abattoir owners for access to over 2,000 culls and checked whether they were pregnant or not. And she asked the abattoir to send a questionnaire to the farmers that had sent them, asking various questions. I was very impressed, in actual fact, that she got more than half the questionnaires returned. Of these 1,100, nearly 290 animals, 25% of them, the animals were pregnant. But when asked in the questionnaire, the farmer, 87% of the animal farmers said, no, it's not pregnant. 2 of them, definitely they were pregnant. And yes, okay, we do have problems with broken legs, etc., etc. So you can understand a very small percentage. Of these 289 that were pregnant, looking in detail, 3% of these 289 the farmer knew the animal was pregnant in the questionnaire, or it was outside the calving pan in block calving codes. A disappointing 20% had had no PD done on them. And 23% were culled because they couldn't get in calf. These are animals that were pregnant when they were culled. The farmer thought the animal wasn't pregnant. If he believed it wasn't pregnant, and then Sally looked at the different stages of pregnancy, the first, second, and third trimesters, and asked the farmer the question, would you have kept that cow? Of the animals that were pregnant in the first stage of pregnancy, 27% of the farmers said, yes, they would have kept it. 53% in the second trimester, 71% in the third trimester. So it's knowing whether the animal's pregnant or not when you're going to cull it. So before culling cows, check that the cow's not pregnant just by taking a milk sample before you dry it off. So to conclude, keep high heat detection top priority. Find the 75% of those that do express the heat and get them inseminated. Keep the production diseases to a minimum to avoid having 25% of those cows that have a headache and they're not actually expressing the heat. And I urge everybody involved to use all the available resources. The farmers should be speaking with the vet and the nutritionist and a geneticist. If you can get them all in the same room at the same time, that's fantastic, to produce a healthy herd. But farmer and vet and use of PAG tests can assess pregnancies efficiently. What do I think is the future for PAG testing? Inline, that's in the milk line, testing for PAG with a digital alert to the mobile and the computer. We've got to get into the 21st century with this. Finally, thanks for listening and best of luck to everyone involved in future UK dairying.
Thank you, Hilary, for a most informative presentation, which highlights the levels of PAG during the lactation and various stages of pregnancy. I will now hand over to Owen Atkinson, a member of the Royal College of Veterinary Surgeons and a specialist in cattle health and production. He will highlight the economic importance of getting cows in calf and gives a vet's perspective on using PAG testing.
Thanks, Jeanette, and thanks, Hilary. Most people who are listening won't know, but Hilary taught me at university, and I never tire from listening actually to Hilary, your description of maternal recognition of pregnancy, because it is fascinating. I share your fascination with it, and it stayed with me all through my working career. So I'm going to do, as Jeanette said, I'm going to start by doing a refresher really on the importance, the economic importance of pregnancy. And then I'll look at a perspective, my own personal perspective, if you like, of how PAG can fit into the role that vets have in helping farmers manage fertility. So dairy farmers are no different to any other business in the sense that you've got inputs and you've got outputs. So your main output on a dairy farm obviously is milk. That's the main thing you're selling. And then the costs come from feed, from labor and fixed costs, feed being the big one, of course. And so it's important to maximize your output for the same amount of input, i.e. get more milk from the same input. And that is the important part of efficiency. Now, if when a cow has a calf, she produces milk at a nice, steady, high level without a decline over a period of time, then it's less important to get a cow in calf. But that isn't the reality. You'll see here, this is a graph showing days in milk, stage of lactation, versus milk yield. The green dots are first lactation cows, and the orange ones are 2+ lactation cows. So you'll see that this is what a lactation curve does. It goes up high, peaking around about 60-70 days in milk, and then it will drop off. Heifers are a little bit flatter. They don't tend to drop quite so fast. But because cows drop off, it does mean that when they get what I'm going to call stale, so I'm saying beyond around 330 days in milk, then they become less profitable. And this graph shows this in a different way. So if we look at a lactation curve, milk yield going high, around about 50-60 days in milk, and then dropping off over a period of time. And we look at the dry matter intake. The dry matter intake will also go up a little bit, but it doesn't drop off to the same degree. So cows giving less milk at 300 days in milk are not eating significantly less than their counterparts earlier on in lactation. Now, applying some fag packet figures to the graph, you can see that the margin early lactation is nice and healthy. It might be costing you £10-11 to feed that cow, but you're getting It might be costing you £4 a day to feed that cow, but you're getting 10 or 11 pounds worth of milk a day. So you got a healthy margin, £6.80. A bit later on, your margin drops, £4.10. And a bit further on again, it's costing a little bit less to feed those cows, £1.80 a day perhaps, but you're only getting £4 worth of milk a day. So a much reduced margin. So you want as many cows as possible at that higher margin area. And that's I think we probably all know that we need to have a reasonably tight calving interval. And this is true for all year round calving herds and obviously block calving herds that don't get that option. If we look at a graph, and these graphs are available through various different bits of software, of a typical herd and the spread of calving intervals, we'll see that you get a lot of cows, depending on the farm, that can have quite long calving intervals, say more than 480 days. And I'm calling these the problem cows. These are the cows that are problem in the sense that they're not as efficient economically as cows that are calving with a lower calving interval. Now, this is your target window in which hopefully all cows should fall. So from around 330-day calving interval to 480-day calving interval. The sweet spot is somewhere in the middle, because that's the most profitable cow, but it's impossible to get all cows calving with a 380, 390, 400-day calving interval. However, we can aim to get as many cows as possible, if not all, calving within that green frame. And we don't really want the ones calving outside that frame, whether they be too short intervals or too long intervals. So that all means, putting it together, that you have a service period of 50 days in milk, I'm suggesting, to 200 days in milk. And this is for an all year round calving herd. It's a tighter window than that for block calving herds. Voluntary waiting period being 0 to whenever you first start serving. So my service period, in order to get your 330 day to 480 day calving interval, is day 50 to day 200. And that's because the pregnancy is around about 280 days. So you just knock off 280 days from your calving interval. And what does that mean? Well, it means for those all year round calving herds, the service window is 50 days to 200 days in milk. And that's almost exactly a 5-month window or opportunity to get your individual cow in calf. And if you divide that by 3 weeks, because that's the typical length of a cycle, then that's just 7 service opportunities potentially to get your cow in calf. And it's important not to waste a single moment or opportunity in that 150-day block of time. Now, reiterating what Hilary said, fertility success is actually a function of 2 things. First of all, getting cows served, and that's heat detection and also, importantly, heat expression. And that really is, again, echoing Hilary's thoughts from earlier on. And then the second thing is, once you've served the cow, achieving a pregnancy, i.e. getting that conception and the establishment of pregnancy due to maternal recognition of the conceptus, etc. And typically this is expressed as a pregnancy rate, and that is a combination of the heat detection rate times the conception rate. And for all year round calving herds, typically conception rates are around about 37%, that's average, and a heat detection rate is around about 45%, and that will give a pregnancy rate of just under 20%. Those are average figures for the UK industry. I'm going to just emphasize or use a theoretical example of Farm A and Farm B to emphasize just how important the heat detection rate is, regardless of the conception rate. So Farm A, this theoretical farm, has a low conception rate, only 20%. Farm B has just slightly higher than average conception rate, 40%. In theory, and this is a theoretical example, Farm A, though, does actually see every single heat, and the cows express every single heat, and they're spotted. So no opportunity is missed to get a cow served if she's in heat. Whereas Farm B is working with an average heat detection of 40%, which is very typical. Now, between those day 50 and day 200, and we have those 7 potential service opportunities, let's see what happens. Well, Farm A, with its 100% conception, 100% heat detection, will spot every single heat, but only 20% get in calf. Farm B, well, they're only spotting 40% of heats, or only 40% of heats are observed one way or another, because that might be because of poor expression or poor detection or combination. They've got a better conception rate, but they get a lower result. They only get 16 of their 100 cows in calf on that first cycle. Let's fast forward to the end of the 7 cycles, and using those figures, you'll see that farm A will end up with 79 out of their 100 cows at the start pregnant. So in other words, 21 of them are going to be called as barren. But farm B only achieves 71 pregnant and is going to be culling 29 cows as barren, which is a much higher proportion. And really that is just to demonstrate how important that heat expression, heat detection is in achieving good results. These are reasonable targets. So I said the average was around about 45% heat detection, 40% or 37% conception rate. These are reasonable targets, I think, for many, even high yielding Holstein herds. Lower yielding herds will achieve better than this. So block calving herds will often achieve better than this because they don't tend to be as high yielding. So 40% conception rate, 65% heat detection rate, and that will give an overall 26% pregnancy rate. That's a reasonable target I think most farms should be achieving or aiming for. But you see, the big gain is actually on the heat detection rate. That's the big potential opportunity that most farms have for improvement, rather than trying to stress too much about the conception rate. Sure, maximize your conception rates where you can and look into why it might be low if it is below your average of 37%. But the bigger gain for most farms is actually improving heat detection. And again, echoing Hilary, a lot of that is about heat expression. Now, if you're achieving those in your 7 cycle or 150-day window, you will end up with 91 out of your 100 cows pregnant by day 200. So now, instead of being an average farm where you might be culling 20 odd cows that don't get pregnant, you only be culling 9 or 9%. So that's much better and much more economic achievement. Now, how can we do it? Well, maximizing heat expression is absolutely key. And there's lots of things that will come into that. For example, the facility design, the floor surface, having space is very important, but minimizing lameness. Go back to Hilary's slides, one of the slides at the beginning, which showed just how health events or poor health events will influence heat expression. And number 1 on that list was lameness. So lameness is something that is close to my heart. Those of you who know me as a farm vet will know that I've worked for many years on trying to improve lameness management on dairy farmers and help farmers do the same. And minimizing lameness is absolutely key to maximizing heat expression and therefore heat detection. How do you maximize heat detection, assuming the cows are showing it? Well, use technology. It just makes sense. It's an additive effect. So in other words, if you're using some technology such as a pedometer, for example, or some other activity meter, and you combine that with visual stockmanship and herdsmanship skills, then that will be more beneficial than using just one of those. So that's more beneficial than just using visual detection or just using technology. But maximizing heat detection through technology is a very, very sensible thing to do. And most farms that I know nowadays will be using some form of technology to help with their heat detection. Absolutely makes sense. And pregnancy test to find the empty cows. So you're not pregnancy testing to find the positive ones. You're really pregnancy testing to find the empty ones. You want to find those empty cows as soon as you possibly can in order to respond to them and try and get them served again. And use the best technologies again that you can do with that. Now, pregnancy testing is generally done through either ultrasound or rectal palpation or a combination of both. And it certainly has been done like that through my career. When I started out as a new graduate vet, ultrasound was really just starting out, and most of it was manual PD, and that's what I did in my first job. Was all manual pregnancy testing, testing from around about 6 weeks in calf. Quite accurate, not as accurate as ultrasound, and using ultrasound you can go a little bit lower. I love using ultrasound. I love to see that 30-day or 35-day conceptus. This is a picture of an ultrasound image of a pregnant cow, pregnant uterus horn, and here is that little 30-day conceptus. And I never tire from just seeing that tiny little dot and its little beating heart, which helps you know that all is well. But also you see the fluid associated with pregnancy, and that's an important sign as well. But the pregnancy testing, in order to be efficient and economic, it's got to be quick, it's got to be safe, it's got to be accurate, it's got to be efficient. Like I say, for my working lifetime, that has been through manual palpation, and more recently, so in the last 20 years, has been predominantly ultrasound. There's some pictures there of some of my colleagues when I was in practice, and here we are, look like a bunch of Ghostbusters. Now, of course, there's probably more female vets, or there are certainly more female farm vets than there are male farm vets that are coming into the profession. Time moves on. There's an expression or a term that is commonly used within the veterinary world of rectal tourism, and that's how farm vets have traditionally spent a lot of their time. It has been the mainstay of the farm vet for many, many years, of doing rectal examinations either with or without ultrasound as part of routine, let's say fortnightly or monthly fertility visits for their dairy clients. And it's often the main link that actually vets have with their dairy clients. However, we need to move on. And I remember being at college 25 years ago and hearing from Hilary then that we needed to be aware of alternative technology that is bound to come down the line and not become dependent on this rectal tourism, as it's termed. There is now sample-based pregnancy testing as an alternative technology. It's been around for a little bit, and it is this is different to progesterone testing in milk. It is looking for the pregnancy-associated glycoprotein, as Hilary has expressed, and it has several potential advantages. It's less stressful for the cow and probably for the farmer. We don't know how much stress is induced with cows through rectal examination. The evidence is quite ambiguous, actually. So I don't take a particular strong view one way or the other, but I think it's something we need to be aware of, is that if we don't need necessarily to be putting our arms at the backside of cows on a regular basis, then we need to keep open eyes for alternatives. Certainly, it's accurate, it's efficient, very time efficient. It avoids cow segregation and lockups, which has to be better for the cow. And again, less stress and hassle for the farmer. And key, it is less dependent on a highly skilled veterinary resource. This rectal tourism doesn't have to take up a lot of our time. And I just question whether it is the most efficient use of our veterinary time. And this leads me on to, this is my personal perspective, if you like, the evolution of a farm vet. And I'm kind of using on the bottom a timeline here of how we have changed the way we listen to music. So the timeline runs from 1950s to the present day. And you can see we used to go from the old gramophone through tape recorders, Walkmans, CD players, iPods, and now Spotify. So things change. And even in that time frame, the farm vet has changed. So, go back to the 1950s, we're looking at the James Herriot era, very much fire brigade work. Moving into, I guess, the bulk of my professional working life, from sort of post-Walkman stage to the current day, it's a lot of that fertility work, that routine fertility work. It's very task-based work. So I'm calling this Vet 2.0. So mending sick cows, fixing LDAs, and doing that rectal work. However, looking ahead to the Vet 3.0, so from sort of now onwards, what's this vet going to look like, and how does that efficient veterinary input appear? And there is an evolution, and vets are moving more into a herd health leadership role, operations management, data management kind of role, and the time spent on farm needs to be efficient. It needs to be cost efficient. I apologise because I'm very conscious of this slide. It demonstrates, or it shows, it might hint that farm vets are all male. Certainly back in the 1950s, they nearly all were. Now they're not. And certainly in the future, we're going to see far more a higher prevalence of female farm vets than male farm vets. So I do apologise because these pictures might indicate that that farm vets are male, and that's not the case. It's just I couldn't find a suitable picture to illustrate that 3.0, which was a female vet. So that's just a kind of a bit of a viewpoint, my viewpoint of where the farm vet profession is going. So in summary, fertility management, it is a fundamental part of dairy farm profitability, and that milk, that lactation curve, and the economic effects, hopefully I've expressed quite well. Heat detection and finding the non-pregnant cows as soon as you can after service is a cornerstone to that good fertility management. And again, hopefully I've demonstrated the reason why that's the case. Pregnancy testing, therefore, is and will remain important. And just like we embrace new technologies for other things on dairy farms, then we must look to new technologies, embrace them where they're appropriate, and opportunities that will help the most forwards-looking vet practices and their clients to prosper. And I think that keeping our options open for a greater use of PAG is an example of just that.
Thank you, Owen. Again, a lot of information to digest. By using the technologies that's available, including PAG testing, it does help our farmers to identify the emptier cows and obtain that sweet spot to get them back into calve. Now we have some questions. The first question is, after administering AI, when exactly can you check the pregnancy status through ELISA Rapid Pregnancy Kit? The test can be done up to 3 times within a lactation, with customers selecting their own parameters. The test can be done 60 days after calving and 28 days after service. Another question we have is, what is the cost of the test? CIS charge £3.50 per test, with recheck results not charged. Another question here is, I use a sweeper bull. Can the test be used if I have a sweeper bull? Yes, the test can be used. Ideally, the test should be done 4 weeks after the sweeper bull is taken away to eliminate false negative results.
Can I come in there, Jeanette?
Absolutely.
Just to add to that. So, I mean, these are pros and cons of different ways of doing pregnancy testing, and I don't suggest that that manual palpation or with or without ultrasound it will be necessarily fully surpassed by this technology at the moment. Although Hilary does point to you know, as time moves on, the panacea must be inline PAG testing. One disadvantage of the PAG test is it will not give you an accurate how far the cow is pregnant. So, for example, if you're using a sweeper bull, it'll tell you whether the cow is pregnant or not, but it won't tell you how far pregnant it is, and that will be something that is different to ultrasound.
Thank you, Owen. Thank you for that comment there. Another question we have here is, why use the test as a recheck? Can it not be used as a primary PD? And yes, it actually can be used for both. As I said, it can be used from 60 days after calving and 28 days after service. So it can be used for both.
Can I come in again, Janet?
Yep.
Sorry, it was only just to say that my experience of PAG testing to date has been mainly farms using it as retests, and there has been work done by other vets on showing the value of using PAG testing for retests, and that's particularly true where any, you know, if a farm has, I think it's more than 2% pregnancy failure rate after they're PD positive, however the PD positive is done, then there's a cost effectiveness of finding those negative cows. There are pregnancy losses after pregnancy testing, and through neospora or other causes, or just natural decline, and it's important to find those cows. However, it is underutilized at the moment as a primary preg test, and there's no reason why it should be.
Thank you. Perhaps either you or Hilary would like to pick up on the next question. It's asking, how do you deal with silent heats?
Ensure that the cows want to get pregnant. basically ensure that everything else in their lives is hunky-dory. They're fed well, watered well, they have a good environment. And then there's no reason why they should show silent heat, or there's less of a reason why they should show silent heat. As a very, very last resort, you could use reproductive drugs in terms of ovsync, things like that. But the majority of animals, given the right conditions to live in, will not show silent heat. I'll be that bold.
Thank you, Hilary. Owen, have you got anything to add to that?
Yeah, I'm totally aligned with Hilary on this one. Again, I think we may be falling into a bit of a trap as vets and farmers reaching for the drugs in order to synchronize heat in my opinion, too soon. Reducing lameness will get rid of a lot of, in inverted commas, silent heats. Reducing lameness is the biggest killer for cows not showing heat. And then, as Hilary says, you know, the facility design and having happy cows and cows that want to show in heat will be the other way to do it. So first establish, are the cows cycling? Most are. It's just they're not showing heat, and those are the ways to tackle it. Get a healthy herd, reduce lameness, ensure the environment is right.
Thank you. Another question we have here is, how long does it take for the PAG level to decline? Well, if we go back to one of the earlier slides, you can see here that after early embryonic death, the PAG level can take 8 to 10 days to give a negative result. You can see on this graph here how the PAG level increases throughout gestation. Therefore, the further along in gestation the cow is, you have to be aware the longer it will take before the PAG level gives a negative result. If we look at this slide that details the PAG decline post-calving, you can see that it could take 30 days before the PAG level gave a negative result if the test is used later on in gestation. For example, to be used as a pre-dry-off test. And I have a final question here. If you have used Receptal, will it change the effect of the test?
No.
That's wonderful. Thank you, Hilary. Nice and sharp and on that one. So thank you very much, everybody. We're running out of time here. But if there is any other further questions, then please do submit them to either info@cis.co.uk, and we will pick those up on a one-to-one basis and get those answers to you. So I would like to thank especially our speakers for such informative presentations today, and also to you, the listeners, for taking time to join us this afternoon. If you would like any further information, please contact your local CIS area manager, and the contact details are showing on screen, or Rachel Fox from IDEXX.